Hello everyone, this is Dr. Prashant and welcome back to Epidemiology lecture series. In this lecture, we will discuss about the topic confounding and effect modification. Confounding is a distortion in the estimated measure of association that occurs when the primary exposure of interest is mixed up with some other factor that is associated with the outcome. Or in simple words, it is about alternative explanations for an association between an exposure and an outcome. Confounding occurs when there is unequal distribution of a risk factor for a disease between those exposed and unexposed to the exposure of interest. So let's understand this with an example. For example, if I want to see an association between diet and heart disease, diet being the exposure and heart disease is the outcome of interest. A potential confounder in this case can be smoking. So what are the characteristics of a confounder? Confounding variable must be associated with the exposure of interest in the source population, and it must be a risk factor for the outcome among the unexposed. It should not be on the causal pathway between the exposure and outcome of interest. Let's see with an example. If I want to see an association between smoking and liver cirrhosis, where exposure is smoking and the outcome is the liver cirrhosis. Here, if I consider alcohol as a potential confounder, let's see whether it is satisfying the above criteria or not. Alcohol must be associated with exposure of interest. So, alcohol must be associated with smoking in the source population. It's true. And alcohol must be a risk factor for the outcome among the unexposed. So, alcohol leads to liver cirrhosis, right? Among the unexposed means, in this case, who are unexposed to smoking, okay? And the third criteria, that is, alcohol should not be on the causal pathway between the smoking and liver cirrhosis. All the three got satisfied, right? And now coming to the types of confounding, there are two types, positive confounding and negative confounding. In positive confounding, the observed association between exposure and outcome appears to be stronger. That means there is increased odds ratio than it really is. And in negative confounding, the observed association between an exposure and outcome appears to be weaker, where we see decreased odds ratio than it really is. So how to identify confounders? Think about exposures that are biologically plausible as risk factors for the disease in question. Do a comprehensive literature review to find out what exposures have been found to be risk factors in previous studies. So now, how to control confounding? So basically, what are the methods for controlling confounding? We can control them at two stages. One, at the stage of study design, and other at the stage of analysis. At the stage of study design, we use restriction, matching and randomization methods. And at the stage of analysis, we use stratification and regression modeling. Let's look into all this very briefly. In restriction, we limit the study to people who are all in the same level or category of potential confounder. Matching, it involves selecting one or more controls that are similar to each case with respect to one or more potential confounders. Basically, we match the case and controls. Randomization, it involves the random assignment of the exposure of interest, that is treatment or placebo group, across two or more groups. Stratification, it involves the division of participants into subgroups with respect to categorical prognostic factors. For example, classifying age into decades or weight into quartiles. And the last one, regression modeling. It is a statistical technique which allows the effects of a whole range of exposures to be estimated, each one adjusted for the potential confounding effects of the others. So all these are the methods to control confounding. And now coming to the effect modification, which is also known as interaction, it is defined as a situation where the association between the exposure and outcome varies by levels of a third factor. Effect modification is an important property of the relationship between two factors and their influence on the disease. Effect modification is not a nuisance effect, whereas confounding is a nuisance effect. Effect modification is real and interesting effect. So we should not eliminate the effect modification or interaction. The investigator has to detect and describe interaction in the greatest possible detail. A simple example, the association between coffee drinking and lung cancer may be present in males but not in females. So here the association between exposure and outcome varied by levels of a third factor, because in this case the third factor can be the gender, because it is seen only in males but not in females. So in this case the effect modifier is the gender. How to distinguish confounding and interaction? Because both sound similar. So what is the method to distinguish these two? First, stratify the data according to the factor under investigation. If the stratum specific rate ratios or odds ratio or risk ratio. So what does it mean, stratum specific? Initially we take the crude rates, after that we stratify them, right? For example, we classify them according to age. So we get values for the specific age group. We call them as stratum specific rates. Okay. So if the stratum specific rate ratios or odds ratio or risk ratios differ from the unstratified rate ratio, that is the crude one, and if there is little variation between the stratum specific rate ratios, then we can say that there is an evidence for confounding. Instead, if there is variation in the stratum specific rate ratios more than is due to chance, we can say that there is an evidence for interaction or effect modification. Let's understand this with an example so that it will be very easy. Okay, let's look into the first example where the crude odds ratio or unstratified ratio is 4. Whereas the stratified odds ratio in stratum 1 is 4, whereas the odds ratio in stratum 2 is 4. In this case, all the three ratios are same, stratified and crude. So there is no confounding and there is no interaction. Now look into the second example where the crude odds ratio is 4, but after stratification, we can see the odds ratio is 3 in both stratum 1 and stratum 2. So in this case, confounding is present but interaction is absent because we got the same values in both stratum, but these values differ from the crude ratio, so there is confounding. And in the example 3, the crude odds ratio is 4, but after stratification we see a completely different values in stratum 1 and 2. It's 0.75 in stratum 1, whereas the odds ratio in stratum 2 is 6. We see a significant difference, right? It is not due to chance. So in this case, we say that interaction is present. Let's see a numerical example. For example, association between coffee and cancer of pancreas. So here the exposure is coffee and the outcome is cancer. Let's see at the crude data. So we make a 2x2 table where in the columns we see cases and controls, and on the left side we get the exposure status. So in this case, the odds ratio is 1.9. But after stratification, because this is the first step, right, to distinguish between confounding and interaction, here if you see the odds ratio among smokers is 1 and the odds ratio for non-smokers is 1. So as we already discussed, if the crude ratio is 1.9 and if the odds ratio after stratification is same for all the strata, then confounding is present. Similarly, if we want to see an association between smoking and ischemic heart disease, so this is a numerical example for interaction. So it is same. First we get the crude data. Here the rate ratio is 2.4. Whereas after stratification, we got the rate ratios for 3 stratums. So stratum means less than 45, 45 to 54, 55 to 64. So we got 3 different values first, and all these values have some difference, right? Because one is 14.86, 3.33 and 1.93. So there is significant difference. We can't say that it is due to chance. So in this case, interaction is present. And one important point, the rate ratio for smoking varies according to age. Age and smoking interact in this case. Okay, that is the interpretation. Thank you.